function can be represented in a variety of ways. It may be represented by a table, roster form, as a set of ordered pairs, an algebraic rule, an arrow diagram, or as a graph comprising ordered pairs in a plane. Let us examine each of these methods, beginning with the tabular method. In the tabular method, a function is a pair of values shown from the left-hand to the right-hand column. Notice that no value is repeated in the first column. The set of values in the first column indicates the domain of the function and the second column gives the range. Next, let's consider the second form, the roster form. In this form, the function is represented as the set of ordered pairs as shown here. In the roster form, the set of first elements in the ordered pairs forms the domain and the set of second elements forms the range. Moving on to the third representation as the algebraic rule, if f is any function from set A to set B, then we can write it using the algebraic rule as shown. Consider this function which maps every natural number to its square. This function can be expressed in the algebraic rule as shown here. It is easy to see the domain and range of the function from this representation of the function as well. These three ways are algebraic ways to represent the functions. Now, let's move on to the geometric methods and see an arrow diagram. In an arrow diagram, the elements of a set are mapped to the other set, such that no element in the first set is left out and no element is mapped to more than one element. In this representation of the function, the domain is the set of pre-images and the range of the function is the set of images. The next geometric method is the set of ordered pairs representing the function plotted as points in the x-y plane. In this form, the function is the rule of correspondence from horizontal axis to vertical axis. Here, each number on the x-axis is associated with only one number on the y-axis. Let us plot the ordered pairs representing the function y equals x squared as points in the Cartesian plane. Note that in this function both x and y are natural numbers. If they had been, say, non-negative real numbers, we would have drawn a curve through these points plotted on the xy plane. A function represents a curve which a vertical line intersects only once.